Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see how we can implement logistic regression in pyspark. I will be using Databricks for this. So in my previous video, I have already explained you about the logistic regression, the theory behind it, what we try to achieve in logistic regression. Specifically in this particular video, I am going to show multi-class logistic regression. So usually in logistic regression, you have multi-class as well as the binary logistic regression. In binary logistic regression, you try to classify the output into two categories. That is what is called your binary logistic regression. In multi-class, you have more than two categories to distinguish. So we are going to implement multi-class logistic regression over here. The reason is most of the online documentation that I saw, they were mostly talking about the binary logistic regression. So I thought let's make a video on the implementation of multi-class logistic regression. I will also cover binary logistic regression later on in my series as well. But before moving on, do remember to connect with me on LinkedIn as well as on Instagram, and I will leave the link in the description box. So let's move ahead and see exactly how we can implement multi-class logistic regression. So basically over here, this was done maybe a month back, but I did not get chance to make a video of it. So the very first thing that we are trying to do is we are trying to import few important libraries. We are trying to import pyspark.ml because we are going to use pyspark.ml, right? So from pyspark.ml.feature, I'm trying to import this particular library. Then I'm trying to, normally just import pyspark.sql function and the SQL type because these are the ones that I'll be going to use as well. Now, talking about the data set. Now everything has to be implemented on the data set. So I'm using my iris data set. Now this data set is one of the data set that I have used very much, especially in my Databricks videos. So if you see here, what I'm trying to do is I'm trying to read my iris data set. Iris is nothing but it is a flower related data set. So it tells you what is the sepal length, what is the sepal width, what is the petal length, petal width, and the species of that particular flower, right? So if you see over here in the data set, you have setosa as one species, and if I come down, you have versicolor as one species, then you have virginica as one species. So you have three species. So now using this data set, I'll try to build a multi-class logistic regression model which is going to predict this species. Now the output species is more than 2. That is why we are calling it as multi-class. If it would have been 2, then we would call as binary logistic regression. Now remember that I will leave the link in the description box to get this iris data set. But even if I don't, you can actually Google directly on Kaggle. You will find exactly same data set. Even I have got this data set from Kaggle itself. You can download this data set iris.csv and you can place it in your DBFS, right? And then I'm just reading it as a data frame. Now you can see that in my data frame, everything is a string over here, right? And this is how my data looks like: ID, sepal length, sepal width, petal length, petal width, and the species which I want to predict using this input data set, and it has around 150 rows. Now basically everything is a string. I just want to change the data type to decimal. So that is why you can see over here I have just done a casting. So from the data frame that I created at the top, right, df underscore multinomial, right, from here I'm just trying to select the column, and using the cast function I'm just trying to change the data type over here, right? So if you can see over here, after changing the data type, what I have done, I have also renamed the column. I have also renamed the column and I have fetched the changed data type columns over here, right? And then you can actually see that I have already talked about vector assembler, right? I have already talked about vector assembler in Databricks over here. So in Databricks pyspark ML. So whenever we are using pyspark ML library, right, and whenever we are trying to implement any of our models, right, especially using pyspark ML over here, we need to provide our columns, right, as a vector, right? So if you see over here using this vector assembler, now this is exactly same thing that I have explained earlier as well, right, in my previous implementation video, linear regression implementation video. So if you see MFT, right, I have imported it as a top, imported it at top. pyspark.ml.feature. Right, from pyspark ml, what I'm trying to do, I'm trying to use this vector assembler where I'm saying that these are my input columns: sepal length, sepal width, petal length and petal width, and this is my output column features. Now this feature assembler, what it will try to do is it will take all these input columns, all these 4 input columns, and it will create a vector column out of it. So all these columns will be combined into one column, and that is what is the use of this vector assembler that we usually do. And then adding a scaler. Right, now basically I want to scale my data set. Right, now I can maybe later on I'll make a video on when do we use scaling, right, why do we use feature scaling. But here if you see, even this min max scaler, right, what I'm trying to do from pyspark ml mft that I have imported at the top, you can see that I am trying to use min max scaler, right, and I am trying to scale my features. Right, so whatever my features are, right, I'm trying to scale them with minimum value of 0 and maximum value of 1. Right, and this is my input column, right, features. So this is my input column features which I am trying to scale over here, and the output is nothing but the features that are scaled features. Right, now you can actually see this is min and max scaler that we are trying to do. Then also we are also trying to do something called as string indexing. I should have explained this in my previous video. I'm not very sure whether I've explained it already or not, but yeah, when you talk about string indexer, right, from pyspark ml.feature, right, that I've imported at the top, right, you basically import string indexer. Now the main use of this string indexer is essentially that it takes in your input column. So let's say this is your species, right, and it gives you the output column, the same output column, but it indexes your string. So what does this mean? It means that if you have seen at the top, like I have 3 types of species: Setosa, versicolor and virginica, right? So when you do string indexing on top of it, it converts a certain type of string to a certain index. So for example, Setosa, it is going to mark as 0, right? Virginica, it is going to mark as 1, right? And then versicolor, it is going to mark as 2. So 0, 1 and 2. So this is how string indexing work. So here I'm trying to do string indexing. Input column is species and the output column, that's just the renaming of the column, right? Species underscore A. Now if you see here, what I'm trying to do, indexer. So this is the indexer, right? In the indexer I have already given what is my input column, what is that I want to do string indexing on. So then I do indexer.fit, right? Indexer.fit, fit this indexer, try to implement this indexer on df underscore multinomial. Now this is the data frame that I have read, right, from the CSV, and I have changed the data type. Dot transform df multinomial. So basically try to use this indexer, right? So this is how exactly we can implement the indexer on the data frame that we have on a specified column over here, right? So that is when you see this df multinomial comes in, and you can also see that you have these columns available: sepal length, sepal width, petal width. You have species underscore A, right? Now if you see, even the data type has changed, right? Now if I try to display this, now if you see this, how does it look like? 0, right? And what are the other values? 2, right? Let me try to check more values. How does the other values look like? So if you can see 1, 2 and 0. So basically a particular species, it tries to identify with a certain index which it starts from 0, 1, 2 like that, right? So it is easier for the computational part. So till now I'm just preparing my data in one or the other format. Now let's try to import the logistic regression. So basically it is a classification problem, right? I've already talked about in my initial videos that this is a classification problem. We try to classify the output. We are trying to classify the output. We are trying to classify it as different species. So if you see from pyspark.ml.classification, import logistic regression, right? So earlier I have also shown you how we can import linear regression. Now in the similar fashion, we are also importing logistic regression over here, right? Till now what I have done over here, right, till my command 12, I've just prepared my data. Now, and I've defined certain functions which I can use to prepare my data. Now here I'm starting my importing my logistic regression model. Now if you see here, once I've imported my logistic regression model, you can see in my command 15, I'm using this logistic regression model and I am saying that my feature column, right, is this and my label column is this. Now this is exactly same as we have done in the linear regression. So in the logistic regression, I am saying that this is my feature column. Now what is this feature column? This feature column is nothing but all my features, right? If you go at the top, what were my features? My features were sepal length, sepal width, petal length, petal width, right? These were my features. Now what I did with those features, I used this feature assembler to assemble all my 1, 2, 3 and 4 features together, right? Now if you see, and also on top of this, right, on top of this, what I've also done is, if you see over here, I have also scaled my features, right? This is what I have done. Now similarly, if you see over here, what I have done, features scaled. So it is basically here I am just trying to say that these are my features which are the scaled features, and this is my label column. Label column is nothing but the output, right? Here what we are trying to do, we are trying to find an optimized version or a more a kind of a linear regression. Logistic regression starts from a linear regression, but it is a little higher version to the linear regression, right? Y equals to mx plus c. Now if you see y is equals to mx plus c, it is going to give you a continuous output, but logistic regression you want to classify, right? And here in the y is equals to mx plus c, what is y? Y is nothing but your output. So label column is nothing but the output, right? Feature column is nothing but your inputs that you are trying to give. Now to build this, now this is just basically the defining your logistic regression model over here. Now there is something called as pipeline in your ML. So whenever you are trying to use pyspark.ml, you can actually use this pipeline, right? Now here what will happen is, in this pipeline you can define what all activities you can say will happen on your particular model. So for example, if I say pipeline is equals to this pipeline, inside this pipeline what will be the different stages, what all is going to happen inside this pipeline. So if you see in this pipeline, my feature assembler is going to work, right? And then my min max scaler, and then my logistic regression. So feature assembler is what? Feature assembler, it is trying to take your n number of input features, right, and trying to generate a vector out of it. Now similarly, min max scaler, it is trying to scale your input, right? And similarly you have logistic regression that I showed you at the top. So together all of this consist of the pipeline. Now similarly, if you see over here, it's nothing but I'm just trying to cache my data frame so that it does not have to recompute and it is little fast. Now if you see, df multinomial is my data frame, right? Now from this particular data frame or this particular data set, I am trying to use dot random split. Now dot random split is just to segregate my training and the testing data. So if you see, I have 80% of my data in the train and 20% in the test, right? So I have to segregate my testing and the training data. That is where I have used this random split. Now after doing this, what I am trying to do, I am trying to train my model, right? And how I am trying to train my model. Now if you see over here, till now, let's understand it in this way. Whatever I have explained you, I have just shown you few different features. Now where does my model starts from? So for my model to start, what I have done, I have built a pipeline over here, right? In this pipeline, I have said this is my feature assembler, and then do my min max scaler, and then do my logistic regression. All three of them I have defined at the top. After that, do the splitting of my data set, do the random split of my data set, give 80% to my training, 20% to my testing, okay? And then till now I have not done anything, okay? Till now I have not implemented this pipeline. This pipeline has not run at all. My data set has not done any feature assembling, it has not done any min max scaler, it has not done any logistic regression. Till now only I have done a random split. After I've done a random split on train and test and got my training and the testing data, what I'm doing, this is where I'm training my model, and how I'm training the model using pipeline. So if you see, the moment I call this pipeline, what is going to happen? My data set, this train data set, right, pipeline.fit train, what does this mean? That go take this pipeline and implement it on the training data set, use training data set and implement my pipeline, right? What will happen is, over here the training data set will go to the pipeline, it will do the feature assembling, then it will do min-max scalar, and then it will do the logistic regression. So this is where your model gets trained. So this is where actually the model got trained on your training data set, right? So this is how you actually have fitted the model, you actually have trained the model, right? And now this is the training data set. Now if you want to see how the output looks like, right, now if you want to see that, okay, I have trained my model on the training data set, now how is my model going to behave with my test data set, right? Now again you can see what I'm doing over here. I'm using this pipeline model because this is my model, right? This pipeline underscore model, this is the output model that I have got after training on the train data set. Now here I'm using this pipeline model and I'm saying pipeline model dot transform test, that use this test data set and give me the results, right? Now results are stored over here. Now if you see results dot display or result dot show, you can actually see over here what is going to happen, right? This is all your input data set. Now where is your let me show you this. Now if you see, this is all your input data set, sepal length, sepal width, petal length, petal width, ID and species, right? This was completely your input data set. And then the species underscore A, what is this species underscore A? I've just told at the top, right, what it is trying to do over here, 0, 1, 2, it has just defined my particular species with a particular number, right, with a particular index, that is string indexing that we have done at the top, right? Now this string indexing, everything has been called by the pipeline. Now features, now if you see, we have also done vector assembling. Now this is the output of the vector assembling. All the features, actually if you see 4.8, 3, 1.4 and 0, 1, these are nothing but these are these values, sepal length, sepal width, right? These are all these values, they have combined into a vector. So this is what is called as your vector. And then feature scaled, we have also done scaling, right? Scaling on these values, right? We want all our values to be between 0 and 1, right? That is what we have defined at the top. So this is how your feature scaling looks like. Now these are all the values that goes to your model. Now once it goes to your model, you can see that this is the output that it has predicted. So if I go over here, this is the output prediction. Now this prediction, right, this prediction is nothing but 0, 1, 2, right? Now these 0, 1, 2 are nothing but string indexed outputs, right? Now to get it back to the actual value, right, that 2 is what? Setosa, right? 2 is Setosa, or 2 is Vergicolor, or 2 is Virginica, right? So what exactly is this? To get it back, what we will do is we will do index to string. So we will do index to string. So earlier we have done string indexer, right? From string we were doing the indexing. But now here in this output, in this results, what we will do is we will do index to string. We already have index, right? In my prediction column I already have index. So I am saying mft dot index to string, right? Input column prediction, right? This is my input column. I have to do string to indexing, and these are my labels. Now this order is important. This order, Setosa means 0, Versicolor means 1, Virginica means 2. So everything is done in an order. So even at the top, if you see, it was done in an order. So this is what I say that output, name my output column as species underscore predicted, and these are my labels, and then do transform results. So this results is nothing but this results, right, that we have got from our model. Now if you see index to string, now what exactly has happened over here? Now if I try to display the results, if I go to the right hand side, you will actually see that prediction species predicted, right? So from this index I have got the string back. So this is what is predicted. It has predicted it as Setosa. Now let's go to left hand side and see whether it was Setosa or not. Yes, it was Setosa. Then it says versicolor, right, in the second, and it has predicted it as versicolor. So this is how your prediction actually looks like in logistic regression. So this is the implementation of logistic regression in using pyspark, right? Now the major library over here is pyspark ML, right, that we are using. So pyspark ML is the major library. What we have done, we have learned how to read a data set, right, and then we have done just a basic the data engineering or the feature engineering part, I would say. So if you see what we have done, we have just cleansed the data a bit, we have changed the data type, and then we have actually defined feature assembler, which helps you to take all the features and put it as a vector. Now this is important because every time you use pyspark ML, you have to give the input in form of a vector. You have to give input column in form of a vector. That is what is called as your feature assembler. Then you have done the scaling. Scaling means that whatever the value is there, put it between 0 to 1, right? You can always define what the value you want over here in the min and max. You have given a min max scalar, and then you have done a string indexing. So if you have multiple string inputs, right, now it is very difficult if you have multiple string inputs. Rather, it is much easier if you have numeric values. So that is when string indexing comes into picture. Now once you do that, what you have done, you have just created your logistic regression model over here, and then you have created a pipeline. Now this pipeline is very important because usually in ML we do this, right? We create, especially in pyspark, we create this pipeline where you have stages, and in the stages we define what are the different stages. So at the top I have defined all these 3 stages, and here I have said that in my pipeline, go ahead, these are the stages. Whenever I'll call my pipeline, these are the steps that are going to happen on the data set that I define. So now what happens, I define my data set, train and test, and then I say that okay, call my pipeline, right, pipeline.fit train. So use it on my training data set. So that is when your model gets trained on the data set. After it gets trained on the data set, you do dot transform and you do dot transform over here on the test data set. Remember that dot fit is used to train your data set. Dot fit is always used with your training data set. When you use dot transform, it is always used on your test data set, right? And then you use this model output, the pipeline model, you use it to perform your operations on your testing data set, to apply your model on the testing data set. Then you get the results. I have already shown you the results. You get these predictions as an output, and then what you do is index to string. You call this function, you basically get it back as strings, right? So this is how your output looks like. Now I don't want to make this video even a bit longer, and please guys don't sleep in these videos because I really feel that there is so much of effort going on, especially in making of these videos, and in fact it is even very difficult for me to explain all of these things in one video itself, because I myself feel that every video should have limited content so that it's easier for you to grasp all the time. So for this multi-class logistic regression, I will also show you in detail, your cross validation, how you're going to do your hyperparameter tuning, all of this, how you can evaluate your model, how you can build your confusion matrix manually, right, as well as how you can, create your parameter gridding, everything, your cross validation, getting the best model output, all these things I'm going to discuss in my next video on logistic regression, because these are major concepts, confusion metrics and all, and I have specially made specific videos on confusion metrics, the cross validation, hyperparameter, all these things. I do recommend watching all of these videos in series, because this particular logistic regression implementation is very important. I am showing you each and everything that we discussed in our previous video in practical over here. So I hope you like this particular video. Stay tuned for the next video, and do remember to share these videos because there's a lot of effort that goes on. And thank you so much for being till here. Do remember to like, share and subscribe to my channel.